Hey, thanks everyone for joining us today. And we do appreciate that you're spending entire day learning about AWS and various different services that we offer, and look at the platform and implement some of the solutions inside your environments. We definitely appreciate that. And as Ron was mentioning, we are spread across multiple different cities. Anytime you have any questions, we are here to help you. You can directly email us or go through Ron as well. So in this next session, what we're going to talk about is we're going to talk about data lakes in within AWS. We're going to talk about the use cases, how we essentially build data lakes, and what are the services that we offer in this space. To quickly introduce myself, my name is Kiran Kupa. I am a senior solutions architect based out of Dallas, Texas. Very similar to Amar, which was the previous presenter. I am a solutions architect who essentially supports multiple different services with the customers. So I'm usually point of contact for customers taking their cloud journey. I help them understand various different services that we offer on the platform. So in this section, what we're going to talk about is building data lakes and what is the easiest way and what are the tools that we bring to the table. All right, so if we rewind a little back and if we think about how the decision making processes have happened in different companies, most companies are data driven or fairly data driven, right? So there's no company who doesn't actually look at the historical data about their sales processes or about the process improvement and things like that. So, but most of the decision making was essentially revolved around enterprise warehouses. So a lot of customers, again, if you didn't know what a data warehouse is, a lot of customers actually use data warehouses, and not there are a lot of customers who actually used simple databases like a SQL Server as a data warehouse in general. So in the past, data warehouse was this single source of truth for everything. All structured data that was there was merged into one big schema within an enterprise data warehouse. The ETL was essentially a centralized process as well, which was heavily tightly coupled. And the changes, if we ever have to make any changes to any kind of data sources or any schema changes that had to be happen, then it was a very, very time consuming process. But today, these enterprise data warehouses are no longer the centerpiece. And I'll give you what the reasons are. So again, the biggest reason is because the data no longer fits the enterprise data warehouse model. So as the data does not fit in these use cases, it cannot scale. What we are looking at is there is more data than people even think about. There is more diverse data as well. So data is growing at more than 10 times every 5 years, and it lives for a very long time as well. Now, think about it in terms of data sets. These data sets could be anything from an email to a chat, messages, to clickstream data, to social networking logs, or to application logs, or networking logs, and various different things. And these data essentially is sitting in various different data sources as well, and essentially data warehousing. And if you're trying to put one fixed schema across all these different dispersed data sets, it's usually not possible and very ineffective way of analyzing the data. So what we see is essentially finding value inside the data for a customer is usually a journey, right? So for most enterprises, we find that deriving the value from the data and how they use the data for business is usually a journey. It could start anywhere from simple business monitoring to like business insights to optimization, where most of the people are today. And then again, essentially, as you evolve into these different use cases, and the more that you analyze, and only then you're able to actually identify the new business opportunities and essentially then come to a business transformation mode. Now, as these processes evolve on the customer side, what we always see is the tools also evolve, the methodologies also evolve. So back in the day, it used to be a simple SQL query to identify, hey, what is the most sold product on my website, to now it's all based on AI ML. So we will talk about some of these different tools and mechanisms that that we have in place to help you build these data lakes in a very efficient manner, right? So let's take a look at what is data lake. I'm sure most of you guys are familiar with what data lakes are, but just for people who don't know what this is, I'm just going to spend about a couple of minutes identifying what that is, explaining what data lake is. So a simple Wikipedia definition of a data lake is it's an architecture which essentially has virtually limitless storage. That's all we talk about in terms of data lakes. However, with AWS, what we think is there are a few fundamental attributes that the data lake should have. And out of those attributes, the very first one is decoupling storage and compute. So think about in terms of if you are building a data lake, or if you're building Hadoop clusters, or if you're building any kind of big data processing clusters on-prem, the traditional methodology was, hey, I'm going to purchase a bunch of hardware. I'm going to go purchase a license for this particular vendor. Then what I'm going to do is I'm going to bring all the data, copy the data, make a copy of existing data, and move into this one single tool. Now, what happens usually is that this tool usually solves for about like 60% of the use cases. Now, for the rest of the 40%, what we do is we go out in the market, we try to purchase hardware again, we find another tool, and then we take this data, we make another copy of the data, we move the data into that particular tool, and then we start analyzing again. So eventually, over a period of time, what really happens is you essentially end up with multiple sources of data, and this is no different than what you were doing before in the past, right? So the biggest attribute is you always want to decouple the storage and compute. Now, the idea is you don't want to make multiple copies of the data. You want to keep the data in one single location, and you want to bring the tools to the data and not take data to the tool. So that's something that we really want to emphasize on. Also, it's about rapid ingestion and transformation. So data has a life. So essentially, data expires. Like if you do not act on the certain set of data, then the data has no value after that. So in this scenario, we want to provide you with various different tools and methodologies to simply ingest that information or the data as rapidly as possible. Security is usually one of the biggest things that most people forget when building data lakes. We usually talk about security in terms of how it is multi-tenancy. So what that really means is now it's a great idea to bring all the different data sets in one single location, but it's also important to make sure that not everybody has access to all the data. It's extremely important that your sensitive data is protected from various different business units that do not actually need access to that particular data. So security in a multi-tenant silo of architecture is extremely important. Up next, we want to talk about something called query in place. Essentially, we want to, as I mentioned earlier, we don't want to move the data to the tool. We want to bring the tool to the data, right? So in this case, we will talk about certain services that will help us simply run a SQL query on the data that is sitting in a storage system. And then finally, it's about schema on read. So how do we essentially build the schema instead of having a fixed schema, which we had in the enterprise data warehouse model? How about we actually create schema on the read, and so that the schema can be flexible and it's not rigidly defined, which again, if you think about it, it takes a lot of time to transform and model even before you ask any question. So it's kind of important to keep this schema as flexible as possible. So these are some of the things that define a data lake within AWS platform. Now, again, today we have more data lakes and analytical solutions that are on the AWS platform than anywhere else or any other cloud provider today. And this is a small list of customers who've been actively running their data lakes on AWS platform. So again, quickly, why use AWS for big data, right? So again, why should you consider using AWS for big data, and why not a different cloud provider? What are the differences that what is the differentiating factor that we actually bring to the table? So when we talk about the attributes of building a data lake, right, what are the different things that we actually bring is the first thing is we want to talk about is agility, right? We earlier talked about how it takes about 6 to 8 months to procure hardware, procure licenses, even before you can actually put the data in a perspective and to get a result out. So if you essentially take up a data lake project today, it could take you anywhere from 6 months to like 2 years to even come to a conclusion whether this has actually worked or not. So with AWS and a cloud platform, you will be able to spin up resources very, very quickly within a matter of minutes to hours, and should be able to get through what you want as quickly as possible. Now, the other definition of agility is also about fail fast. Now, a lot of times you don't know if a certain approach is going to work for you or not. So the idea here is to simply pick up a use case, try and solve for it as quickly as possible. And if it does not perform, or if it does not work for your business use case, ditch it. And you don't want to keep continuing on the same path. So you want to simply fail. If you want to simply fail, then fail, and then move to a next solution, which can essentially help you solve your business cases. Now, again, if you remember this, from the cloud computing perspective, it's all pay-as-you-go model. So the cost of experimentation on the AWS platform is extremely low. Now, so Agility is one part of it. Now, let's say, for example, you essentially found out a particular use case that actually works for you. Then what you want to do is you want to simply take that small use case and you want to scale it as quickly as possible and as seamlessly as possible in a very non-disruptive way and a very cost-effective way. So essentially, this is where the scalability of the cloud platform helps you. And we can help you with various different services in a different model based on server-based or serverless-based services that can essentially help you simply scale this and solve your big data problems. Now, we also have broadest and deepest set of capabilities. We will talk about a bunch of services throughout the presentation, and we will realize that how many services we have to offer in the space, and the functionality that they provide is pretty deep as well in terms of different use cases. Again, keeping it cost low, very important. We will talk about some of the cost lowering mechanisms like reserved instances and transient clusters at a later point. But again, that's something that is very attractive when it comes to the cloud providers. Now, it's also important to get to faster insights. As we talked about, it's all about solving problems as quickly as possible. And how do we get to that? We essentially give you a different set of data migration services and tools. And these data migration services and tools will help you get there as easily as possible. So, if you think about building this pipeline, right? So let's think about what are the different components that go into it. So this is an example of a very simple pipeline of a data lake. So the first component is the data comes in, which is essentially an ingest or a collection stage. Then you essentially want to store the data, then you want to process the data, and you want to analyze that data, and then consume the data. So these are the simple 4 steps. Excuse me. However, when we talk about building a data lake within AWS, we actually want to talk about the business cases. So it's never about the tools or the tool set. It's more about the business cases that you're looking to solve for. Like as a business, you might have hundreds of different cases that you really want to solve for. And there might be a lot of things and a lot of ideas within your company. But the idea is that we propose from AWS is have a very short list of business cases that essentially can give you a direct outcome, which can essentially impact your customer base. Like, for example, I'll share you some of the starting points that we had with customers. Let's say, for example, if you are into retail business or if you have a call center, like which most customers do, by the way, right? So let's say, for example, a simple use case might be improving response times in a call center. Or again, you might have different response approaches and times depending on the channel the customer is communicating with you. But again, you essentially want to standardize the process as much as possible and see that you can get your first call resolution as quickly as possible. So how do you crunch the data in the backend and get to that customer outcome, right? That's one of the use cases. Another example could be IoT data. If you are in a manufacturing process, if there are different uh, different sensors out there in the field. If you're in oil and gas, these sensors essentially are very critical in the functionality and operations of these tools. You want to crunch the data as quickly as possible. If you're into financial services or if you're into insurance business, fraud detection is one of the most common use cases. It could be something as simple as a credit card was being accessed from some random location, looking for unusual patterns in the usage of a user and things like that. So these are some of the usually use cases that we see with most customers. And now that we essentially identify that use case, we want to go back and match the data that is available for us. And this data could be very simple. It could be sitting in a monitoring system, in a logging system, or it could be simple workflow logs that you have in process today, or it could be like a little more complex like ERP systems, or maybe some databases that are sitting on your on-prem data centers today. So the idea is, again, start with the business case and work backwards to match the data that is available, that is needed for you to process this information. Now, how does so this is how a typical data lake looks like conceptually within AWS. If it seems like a busy slide, let me break this down for you. If you look at the center, this is where the center of the data lake is usually a storage system called Amazon S3. We will talk about S3 in a couple of minutes. So S3 essentially is a centralized, virtually unlimited storage that we define the data lake as, and we want to bring the data and store the data in an S3 bucket. Now, on the left-hand side, if you see, there are a lot of different ingestion mechanisms depending on the data sets that you have, and we'll talk about the ingestion mechanisms as well. So once the data is ingested through these different mechanisms or tools or services, we want to put that data into a centralized S3 storage buckets. So once the data is in here, it is usually it's a good location. It essentially scales scales virtually, has unlimited storage there. But the problem with having the data simply in a storage location is that if the data is not cataloged, it's of absolutely no use. So we do have services that can essentially help you catalog the data and to put some meaningful information around that, so that when you need the data, you know exactly what and where to look for. And we will talk about services like Glue in the cataloging space. Outside that, we also talked about security as a very, very important aspect, and we have different tools that can actually help you secure the data inside the S3 bucket, or even access to various different tools. On the right hand side, we have these processing and analytics tools. If you look at how once the data is in here, we talked about decoupling the storage and tools, right? So the tools, the compute essentially is going to consume the data directly from the source buckets, from the S3 buckets, and then essentially start crunching the data from there and gives you what you need. Now, you don't have to always move the data from the S3 bucket to the tool. You can simply run these tools on top of the data that is sitting in S3 buckets. That's fundamentally what decoupling is between storage and compute. So now let's take a look at why is S3 so attractive? Why is S3 so important for a data lake? So if you are not familiar with what S3 is, I'll give a quick 2-minute overview of that. So essentially, it's fairly durable. It gives you 11 nines of durability, which is quite a bit. If you're trying to achieve the same level of durability inside your data center, it's almost impossible or completely cost prohibitive. So we, at economies of scale, we are able to provide you with 11 nines of durability for the data that sits in the S3 bucket. Availability, it's available for 99.99% availability. That's what it's designed for. Super high performance. So it's also important to make sure that it's performant, because if you have these various different tools accessing the same data at the same time, you don't want to be constrained by simple resources like CPU, memory, and IO, right? So the way that S3 is, it's not sitting on a server. We have our secret sauce on top of it, and essentially it makes it very, very performant. So you can do multi-part uploads, multiple get range gets and things like that, and it still will not, you will not see any kind of degradation in performance when using S3 as a data source or a storage location. Security, very important. With IAM integration, we provide you with very, very fine-grained security for the data sets. It's fairly simple to use, it's scalable and affordable, and the most important thing is it essentially integrates with various different services like EMR, Redshift, DynamoDB, Athena, and these are the services that were on the right-hand side in the processing side of that data lake diagram we saw earlier. So real quick, just to quickly take a look at what those ingestion methods are. From the rapid ingestion methods, the tools that we typically talk about is if you have like things like IoT sensor data, clickstream data, then we talk about services like Kinesis. We can ingest the data from your databases. It could be Oracle, MySQL, MongoDB databases, SQL databases, or RDS, whether it be on-prem or the cloud. We can simply point tools to these databases and extract the data and put that into S3 buckets. Data could be sitting on-prem ERP systems, mainframes, storage devices, or if you have like archival data, we have services called Snowball, which essentially is a hard drive. We can send it to you, and you can load that up and send it to us, and we can dump it into S3 buckets. And for anything that has to happen synchronously or asynchronously, then we have services like Direct Connect, which essentially is direct MPLS network connectivity between the data center on the AWS platform. Now, the fundamental idea here is to simply bring data from all these various different sources into the AWS S3 buckets. So how does this looks like? If I have to put that exact same pipeline, the 4-stage pipeline, into something more with the AWS services, the data comes in and sits in the S3 bucket. Now, once the data comes in S3 bucket, it's still raw data. We want to make sure that we process the information with tools like Hadoop or EMR, ETL. We're going to run some kind of ETL job on top of it. Or maybe use a completely serverless service like Glue. And once the data is ETL, we essentially store the data into another S3 bucket, which is a process bucket. And then based on your use case, you can bring different tools to the table for if you, or like maybe move the data into Redshift, Amazon Redshift, which essentially is a data warehousing query type scenarios. So we have the flexibility of changing this pipeline based on the use case, and it could be multiple different pipelines for the exact same use case as well. So it's fairly flexible. It's completely decoupled in the way that you want to run it. So from processing the data in place, as we talked about, the services like Athena, Redshift Spectrum, SageMaker, and Glue are the services that can actually directly work with the data sitting on Amazon S3. So again, ultimately, as much as possible, we want to leverage the process data in place with the focus of getting answers without have to moving the data into a different tool or location. So for example, in this case, Athena is a service. You can simply run ad hoc SQL queries. Spectrum is a data warehousing type query service. If you are using Redshift as a data warehouse in the AWS platform, then you can extend the queries with Spectrum to Amazon S3 as well. SageMaker for machine learning and model training at scale. And Glue is the tool for essentially helping you cataloging and transform the data in place. So typically when we talk about collecting the data, so once we gather the data, it's also important to make sure that you choose the right formats for the data. So again, there is no such thing as the right format or the best format, but there are some recommendations from AWS. So again, every data set involves like different trade-off options. So most data sets that we usually see, they come in CSVs or TSVs or JSON files. But again, typically we recommend that having a columnar compressed are generally preferred, like Parquet or ORC, right? Those are the different considerations. So here's a simple example, right? Why is it so important? So in this case, we are talking about processing a log file. And this log file, if you look at the table at the bottom of the slide, the data set essentially is 1 terabyte of a text file as a log file. And if I have to take this and store it, it essentially is 1 terabyte. Query time is about like 237 seconds, and it costs you about like $5.75 to run a query against the data inside that file. Now, if we take the exact same file and if we convert into a Parquet format, then essentially the size is shrinked to about 130 gigs, and the query time is much faster. It's about like it's about 34 times faster. And if you look at the cost added, it's like 99.7% cheaper. So it's important to understand what kind of data is coming in and how do you want to ETL the data, modify the data, and make sure that essentially is very effective in terms of what you're trying to achieve. So in this case, right, so talking about data preparation, typically 80% of the work in the building a data lake is about data preparation. It takes a lot of time collecting and refining the data to your use cases, right? It could be IoT data, relational, non-relational, whatever that is. Essentially, a lot of heavy lifting is done at the data preparation stage. Now, how can we help you here? Now, you could do it one way. We can essentially run your own Hadoop clusters with things like Apache Spark and try and see if you can reduce the data and make catalog that information. However, if you are looking at a service called Glue, in this case, which is essentially a serverless data catalog and ETL tool provided by AWS. Now, the AWS Glue service has fundamentally two fundamental functionalities. The first one is data cataloging. As we talked about earlier, data sitting in a bucket is of no use unless you catalog that information. So Glue data catalog has something called as Glue crawlers. And what these crawlers do is you can simply point these crawlers to a data set. It essentially automatically discovers the data and extracts the schema from that particular data. And this is done automatically by the Glue service. Now, the second functionality of that is the ETL job authoring. So now, essentially, so once you have that data that is sitting in there, if you want to run an ETL job on this data, we can help you provide that actually automatically generates a customizable ETL code. So you don't have to worry about writing the ETL jobs from scratch. We provide you with a template, and you can use the template and you can make it as simple or as complex as you want. So essentially, it gives you that customizable code that you can simply customize and run it for your ETL jobs. And the best part about this is it's completely serverless. You don't have to worry about provisioning servers in the backend and running and maintaining the entire infrastructure in the backend. So it's a pretty powerful tool in terms of data cataloging and ETL job authoring. So let's take a look at a simple example of how this really works, right? So let's build a simple data lake. So in this case, whether it be log analytics or clickstream data or IoT sensor data, let's take a look at that. So from application point of view, we can use Kinesis as the ingestion methodology. We can, because this is high speed incoming data, we can use Kinesis, put that into an S3 bucket. And what we're going to do is, because these data sets are really small, and what we're going to do is we want to run an hourly job to compact the data into a particular format and then run an ETL and put that into a processed bucket. And from there, you can simply use any tools that we talked about in terms of Athena or like EMR or data warehousing or machine learning, SageMaker, anything that you want to use on top of that particular data. So this is kind of an example of how a data lake is usually built. So This has been the standard process for a very long time, and our customers have taken effort in understanding all these different services. It takes some experimentation, a little bit of experimentation to understand the services, build these tools together, and go through the process. So what we've seen is we essentially bought this building a data lake from a few months to years to maybe a couple of months. However, our customers have been asking about, hey, you know what? This actually is taking a long time. I mean, building a data lake takes us about 2 to 3 months because all these different tools are taking a long time to be like set up and maintained and managed. So again, customers ask us, okay, what can we make this even more simpler? So this is where we introduced a service called lake formation. So lake formation essentially simplifies all the different steps that we talked about so far: the ingestion, the cataloging, the using of tools, and things like that. So lake formation essentially automates the process of identifying, ingestion, clean, and transform the data. With lake formation, you can simply move, store, catalog, and clean your data much faster. In the second step, you can essentially simply enforce security policies across multiple services. So once you have data sources set up, then you can define security, governance, and auditing policies in one single location. You don't have to go into multiple different consoles and do differently in different places. Now, the third thing that we can provide, the lake function provides is that it can essentially help you gain and manage the information of data sets and their appropriate business use cases. And simply within a single console, you are able to actually gain new insights as quickly as possible. So how does this data lake, how does lake formation work? So let's take a look at that. So we talked about this build stages, right? The ingestion, the security, and the analysis part. So if you look at the skill set that is required, you will need different personas to actually run through these different processes. You need data engineers who understands the ingestion, the cleaning process, the moving of the data and things like that, and prep and catalog on the data sets. Now, so the simple steps required is, if you are building this data lake, there are multiple locations, mapping the tables, running ETL jobs, creating access policies, and all these things. So there are a bunch of different things which are usually a long process and makes it a little time consuming and also sometimes very error prone, right? So what we have done with a lake formation is we simply took that and made this a fully managed service that enables all these different roles in one single service. So what does that look like? So if you take a look at the data lake stack still has the same S3 as a data lake storage system underneath it. It provides you with the same tools. It still leverages AWS S3. Then we essentially provide you with a simple, very simplified ingestion and cleaning mechanism for data engineers to build much faster, which includes something called blueprints, which we'll talk about in a minute. And then essentially, then we're going to talk about fine-grained permissions, how it can be set up in one single location, and then also use all the different services. So it's essentially the exact same thing, but we have transformed and we have streamlined most of the processes for you. So how does it work? If you look at the console today, then it is essentially it's 4 stages, and within the 4 stages, we have something called blueprint. So blueprint essentially helps you ingest the data from various different data sources, whether it be databases or logs, into lake formation. It could be a one-shot or incremental uploads if you want to. So with blueprints, what happens is you simply, from your point of view, you're simply pointing us to data source and tell us where the data is. And we actually take care of all the things for you, which is discover the data sources, automatically convert the data formats, convert partitions, keep track of data that is already processed using markers, and we can customize any of the above. So the good part about the blueprints is it's really customizable as well. So when you log into the AWS console today, this is how you see it. It's as simple as the first step is to register the data path where you want to put it. In the second step, what you're doing is you're simply picking up blueprints, and there are a few blueprints that are already available to you. You can simply take a blueprint and then give the source and import source and import target, and the import frequency is what you define. It's a fairly click-through process, and what we do in the backend is we essentially create this entire pipeline of different things. Now, this is a very simple sample workflow. Again, this could be very complex depending on your use case and how you want to do it. However, as I mentioned earlier, the good part about this is it's completely customizable. You can do whatever you want with it. So you can actually make it more simple or more complex if you want to. Now, if you're wondering what is the difference between lake formation and AWS Glue, because we talked about Glue as being the fundamental service. So again, blueprints are heavily leveraged as a functionality of Glue. So think of lake formation and Glue, lake formation as a higher level service than what Glue can provide with you. So the part in yellow is the Glue's functionality, and the lake formation is the blue thing on the top, which is essentially encapsulating everything. So what have we done with this? We essentially made this much easier for customers. So again, it's smarter as well. We use a lot of machine learning algorithms in the backend. So if you have issues like deduplication of data, record matching, which is usually common problems when you're processing the data, then these are some of those different options. And we essentially take care of all those for you in the backend. You don't have to worry about it. And under the hood, we use something called as a fuzzy deduplication logic with the machine learning algorithms. And again, you don't have to know about this, but again, it's part of the service, and we take care of all those things for you. When it comes to security, right? So after you ingest the data with the blueprints in terms of security, what we do is now you don't have to go and give access to individual data sets, permissions to individual data sets. Now the security is controlled in a centralized location using the services. So if you look at the right-hand side, the analyst who is trying to integrate the services, they get the permissions to the service and not the data itself. So once you set up the service permissions, any tool in this case, which is Athena or Redshift or Glue, will go and get access to the data sets that the user is required to have. So think about in terms of, let's say, a database permissions, right? You can actually go very fine grain in terms of column names to the data types and very fine grained. The permissions in this case are not JSON policies. It's more of a grant and revoke kind of policies like in a database system. So you can essentially have user one have a certain set of permissions and user two has certain set of permissions. And the good part about it is the user one will not know the entire data, what the entire data set is. They are only limited to whatever they can actually view, which essentially helps you have fine grained control and better access to the users. Now, again, if you're worried about why, what is the difference between IAM and this? So essentially, these permissions actually work in conjunction with IAM, makes it much more easier in terms of integration. So the process is very simple. Lake formation on the right-hand side, if you see that, it essentially is requesting temporary credentials to the objects. And once you have temporary credentials, you get access to the data sets that is available out there. Now, from the lake formation security process, as I said, like the user, if it's trying to run a query, it initially goes to the integrated services, and the integrated services are the ones that request for a particular access. And there are short-term credentials that are rendered out with from lake formation, and the short-term credentials are being used to go get the data that is needed from the S3 buckets. So it essentially makes it much more secure than running and controlling access on the S3 buckets directly, which would be a very cumbersome process. So in this case, if you're trying to run a query on table T, that is how it's going to work. Now, on the third stage, we talked about the different analytical jobs, right? So we talked about getting the right tool for the right job. So we don't have a whole lot of time to cover all these different tools because it really depends on the use cases. But again, at the high level, right? All these different processing and analytical tools that we have, like Athena, it could be EMR, it could be Redshift, it could be QuickSight, it could be RDS, SageMaker, Lex. So we have plethora of services that can actually help you. And again, if you move into the higher level space, we have like various different machine learning services for various different workloads. So with that, I would like to conclude this presentation. Again, we don't have a whole lot of time to go through all these different services in the space in terms of processing and analyzing, but the idea was to give you a high level understanding of how a data lake is built. And with the new tool, which is the lake formation that we introduced last year, or a year before that actually. And lake formation essentially makes it much easier for people who don't have the expertise to actually hire data scientists and data engineers to go through the process. We essentially streamline most of it. And the good part is it's also customizable. If you want to make it more complex, you always have the flexibility to go and build more complex workflows with lake formation. So with that being said, I think I have about like 5 more minutes. I'm going to let me go and take a look at the Q&A and see if I can answer any of those questions for you guys.
Corinne, one of the questions came out was, do you know any of your customers who are using data lakes for COVID-19 contact tracing or anything related to pandemic data analysis?
Yes, we do. So we actually announced COVID-19 datasets that are available publicly that you can start utilizing. So again, there are templates around it that can be built as a quick starts. And I can send you whoever that question came from. I can find the datasets and the blog article that was written just to process the information. I'm happy to share that with you guys.
I'm wondering if that's a good example. And I want to stay away from any politically controversial subjects, but one of the challenges in testing was you had different formats. Some people are faxing in results, some people were electronically transmitting results, but there wasn't really a standard template for accepting data. Isn't that, in general terms, Corinne, a perfect example for using a data lake to help organizations ingest different types of data and then avoid a lot of tedious work trying to format the data, but then take advantage of AWS capabilities so organizations then focus on what to do with the information rather than simply making it fit within your rigorous traditional data warehouse or database?
That is correct. So COVID is a really good scenario, right? It's a really good example scenario, right? So what I mean by that is now the testing or the numbers or whatever data that is coming out from the field. If you look at the data sources, it's coming from various different data sources. At the same time, that data has a very limited value. What that means is the data is only good for one day. So every single day or every single hour, you simply want to crunch those numbers and get the results out. You cannot wait to build a data lake for a few weeks or a few months to get some information like that. So when you have fast moving data like that, when you have data that actually expires within a few hours, building a data lake and processing the information as quickly as possible in a very efficient way is extremely important. And this is a very good use case of building a data lake on AWS platform.
Got it. That's interesting to me. It's not only analyzing and ingesting different data types, but it's doing so extremely quickly and extremely accurately. Another question that came up in the chat was, how do you go about maintaining data integrity as you go through the data refining process?
So the ETL jobs can essentially include multiple different things. So let's say, for example, when you talk about data integrity, I'm assuming that you're talking about protection of the data and also making sure that the data is not compromised at any point. So again, with fine-grained controls like IAM and the lake formation policies, what you can do is when you process the information, when you're compacting the information, there are various different other security tools. You can essentially we use KMS for securing the data, making sure that the data is encrypted from end to end in the entire pipeline. That's one way of doing it. Fine-grained control permissions applies at various different levels. So if you want to make sure that nobody has access to this data, then we are essentially completely locking it down to particular users or data sets or tools that you can use. And also you have every single piece of data that goes into nested bucket is completely logged and audited using CloudTrail. So from the data integrity point of view, encryption at rest, encryption in transit, and maintaining the audit trail of the data coming in and going out, essentially everything can be done on AWS platform.